Hello and welcome to another game engine video for Cultist Astronaut. Today we'll be taking a look at the dialogue system and how it works. If you enjoy game development videos, please consider subscribing and checking out my other videos. Also, if you have any questions or would like to see a specific part of the game engine, feel free to leave a comment below. Without further ado, let's jump in and take a look at the dialogue system. So this week we've been working heavily on the dialogue system, re-implementing what we had from Unity into the game engine. And as you can see on screen, we are able to render our two characters using spine on the left and right side. So you have the player over here with Gunroy, his trusty demon gun. And then we have one of the characters you can meet on Excoriya and also on some of the other planets, known as the Eldritch Tourist, who has, oddly some resemblance to Gunroy, which ties into the story of our game. Anyway, when you interact with a character, so let's see, if I exit the dialogue, you can see I can walk up and interact with NPCs in the world. And what happens is it starts off with there's like a start node in the graph, which happens to be this welcome back goat. So he actually remembers me talking to him, and we'll take a look at how that branches in the dialogue tree in a moment. And then I can actually talk to him, ask him questions. He'll tell me that we're on planet Excoriya, and so on. And this is all powered by the dialogue tree. So if we go to the asset browser and we type in dialogue, you can see we have Eldritch Tourist Excoriya1.dialogue. And if I click edit, this opens up the dialogue graph, which is the new editor that we've been building. And you can see here that there's a couple nodes that we have. For example, we have isTrue, which checks to see if this variable is true or false. And if it's false, we haven't met him, then he'll say, "Hello, fancy meeting you here." If you have met him, we actually roll a dice and we pick between three options using the probabilities selector. And we pick between one of three responses, which is welcome back, goat, did you forget something? And then the last one, as much as I would like chatting, we really need you to murder the king and his goons. And in the game, you've noticed that it actually said welcome back, goat. And the probability selector is pretty simple. You can type in numbers and they're added together. So we have 5, 4, 2. So that would be 11. And then for the first option, it would be 5 divided by 11, which is a little bit under half. So this option has roughly a 50% chance of triggering. Then you have 4 out of 11 and then 2 out of 11. So this last one, as much as I would like chatting, has the lowest chance of triggering. And we can just use these to kind of spice up the dialogue. They've been used in other scenarios to kind of create interesting dialogue trees. But this is a really simple use case where you just kind of like pick a different message randomly. Also, you can set variables. So if you go down this branch where you haven't met him yet, we actually set the tourist variable to true so that the next time you do go through the tree, it will pick that. So there is some persistence. If you talk to somebody and trigger different variables, they will remember those numbers, those values, and that can affect their dialogue. We also have jump nodes. These are more of an organization mechanism. Sometimes in a dialogue tree, you want to jump back to the beginning of the tree, or you want to jump somewhere else. And this can actually clean up a lot of the graph, so you don't have like lines that cross over each other. You can imagine if you need to wrap back to the beginning, these Bezier curves, right? You don't want this Bezier curve to like go all the way back to the start, because that would look pretty messy in the graph. So we use these jump nodes to jump to a specific node. So you can see here, this one actually jumps to node 9, which is a multiple choice. It actually skips over this option. And then of course, we have another jump node over here. So if you go down this chain, this one actually jumps to this subgraph, which is basically the goodbye. So you can see See you on the flip side, have fun storming the castle. And if there is no node, it just exits. And so this is the goodbye node. And you can see it's connected to the see you later. And we actually jump to it over here as well, I believe. Let me see. Actually, no, that is the only see you later. But yeah, sometimes we have different see you laters throughout the graph, and they all connect to the same exit point. And so jump nodes are useful for just that. This tree is actually incomplete. There's actually much more to connect to it. We just haven't mapped it all out. The two primary mechanisms that we use for dialogue is the dialogue node and the multiple choice. So dialogue just puts a message on the screen, and then multiple choice will give the player 4 different options. And the dialogue code is kind of interesting because what we do is we actually step through, we actually show the option, and then we step through until we find a multiple choice node, and then we present these options to the user. And then this is considered a stopping point, right? It actually waits for the user to select one of these 4 options before continuing. So the entire node graph doesn't execute. We execute one or more nodes, and then we reach these stopping points where we wait for user input. Another nice thing about this, and this is not something I've programmed, this is part of the IamNodes library, which I will link in the description. But there is this nice minimap that you can use to kind of jump around. I also programmed my own jump function, so on the jump node there's this go to button, which will actually snap you to the node. It also selects it so you can see it's highlighted. And we can also delete things, so let me actually just stop this. If I want to, I can delete nodes, which will delete their respective links. I can also delete links. I can relink. I can link to something completely different, right? And then if I close this, right now I don't have a save button, so, and this is all work in progress, so right now I just save when you close, which we definitely don't want that in the final version, but for now it's useful for testing. And you can see in Fork, this is my version control tool, you can see that I've changed, I guess I changed the variable from tourist1 to tourist. That's a bug that I need to fix with the text input. Let me just discard that. But you can see here that I've changed the node connection, right? I've also deleted a node. And then I also removed some node connections. Remember, I deleted a link, so that is what you see here. This node no longer has a next node. And if we want to, we can actually take a look at this file. So if we go to the dialog file, you can see here that it's just a simple text format. So every node has an ID, and then the nodes also have a type. And if I open up the header file for dialog, you can see these are the different types we have. We have is false, is true, probability selector, etc. And all of these are numbered, starting from 0. So this is 0, 1, 2, 3, 4. And you can see this first one is type 1, which is true, which lines up with our first node that we saw on the graph where it was checking to see if this variable was true. We also serialize the position. This isn't useful for the game, but it is useful for the editor. So if we don't serialize this, then when we open the graph, we don't know where to put the node. And so we save all the positions so that we can spawn the nodes in correctly on the graph. And then the next nodes, these are used to link the node to another one. So node 1 is connected to node 2, and node 2 is type 2, so that'd be 0, 1, 2. So it connects to a probability selector. Here are the different weights that we use, and then corresponding with these numbers, so weight 0 is connected to next node 0, which happens to be 4. And so you jump down here and you can see it says welcome back, goat. So we have a very simple text format that we've created ourselves that we read in. One thing that's important to note is we do support multi-line text. So as you can see here on node 19, we actually break our lines up using these /ns, which is a typical thing you do in programming to indicate that you want a new line. And when we parse this in, we actually look for these and insert in our text renderer. We actually move the text down, and we'll take a look at that in a moment. We also support quotes. So you can see we have escape characters for Xcoria as well. So that's how we were able to insert quotes into the actual text. So yeah, let's take a look at the code now. So in the dialog file, we already took a look at the dialog node type. Let me actually close this window here. This is all the data we need for a dialog node. We don't split the nodes up into multiple structures for each type. We use a enum to distinguish what the type is, and then in the dialog node, we just put all the possible variables that we need. And I've kind of organized this by the data that I consider hot, that is used by basically every node, and data that is considered cold, which is used by specific nodes or not typically used by every node. And the type, basically the type tells us which data to use and how to interpret it. And then of course, for now, we have some GUI data here. And this is here because we want to serialize it out to disk in that file format we took a look at. Dialog data is a very simple structure. It basically just holds our collection of nodes, and then it also caches the next ID, which we use to insert new nodes, which I actually forgot to show. If we go back here and we edit the tree, you can actually add new nodes by right-clicking and selecting between these different options. So a designer can come in and add new nodes and expand the tree further. We also support different variables. So in the tree, you saw that we had set variable. Right now, we were setting a Boolean, the tourist variable to true or to false, based on whether or not you've met him. In the future, we're going to expand this to support integers and floats, which these are the three common variables that we use in dialog. And then, of course, we have a structure that allows us to represent a dialog variable in memory. I'm taking advantage of a union to compress and reduce the space. So int value, bool value, and float value occupy the same part of memory, and then we use this enum to distinguish between the three different types. The Blackboard is where we store all the variables. This is considered global right now. We do have a limit, and I'm looking into changing this so that it can expand. But the important thing here is that all the NPCs, all the dialog trees currently share the same global Blackboard. So if you meet the tourist and then you talk to a different NPC, it can technically check to see if you've met the tourist. So this means that if you talk to somebody, you can talk to somebody else and have them recognize that you've already met the previous NPC. So that's very powerful. The Blackboard is useful. However, this system's going to change quite a bit because we want to be able to scope variables to a specific NPC, but also have global variables. So this is going to evolve in the future. And then we have some helpful nodes like get dialog node. And this is used, it's a very, very dumb search function, which just linearly searches through the array and looks for a matching ID. We're probably going to optimize this with a hash map, but this is currently how we look up a dialog node in the collection using an ID. Okay, so the next data structure we have is the dialog step node. This is basically the data we get when we step through the dialog once, and it gives us back the message node and the choice node. Earlier, when I said that the dialog system basically stepped through and then waited, right? It starts at like a dialog node, for example. Let's say it says welcome back goat. It will actually step through until it finds the, oh, this is all messed up because I need to reload it. Let me do that real quick. Just discard these changes. Okay, there we go. So basically, let's say we start off with welcome back goat. It will actually step through, then jump to the node, the multiple choice, and when it finds a multiple choice, it will stop, and then it will wait for the user. Well, what this dialog step data does is it captures that message, which was welcome back goat, and then also captures the node we need for multiple choice. And down here, you can see that we have a function called step dialog, which takes in the dialog data, takes in the Blackboard, and then returns the step node that we want, or actually it returns the data here, the dialog step data that we need after it performs a single step. And you can see it's a very simple switch statement that kind of goes through, performs different options. For example, the probability selector will select a random number, and then it uses this accumulator to basically roll a dice and figure out which option to select, right? And then at the end it says, okay, I'm going to step to this next dialog node. And just to kind of show the rest, we have the dialog node, which sets the message node. It also has this wait function. This is what tells the dialog system to stop and wait for the user. Set variable accesses the Blackboard and then grabs the variable and then updates its Boolean value. Like I said, we don't currently support the integers and floats, but in the future we will be expanding set variable to support those two types. The jump node is the most simplest one, right? It simply just grabs the next node and stores it in the step node. And then multiple choice sets the choice node in the step data and then triggers a wait. We always wait on a multiple choice because that requires player data. Whereas with dialog, we actually check to see if we've found one or not. If we found a dialog node and then we find a second one, then we need to wait. And just to kind of show that in the graph, if I have two dialog nodes in a row, so for example, if I had something like this, where the NPC says something and then he says another word, this point right here is where the player would have to click the spacebar or the enter key to go to the next message. And so wait is what we do to pause that. And let's see, what else do we have here? We have functions for adding a node, getting and creating a variable. And you can see here I have nodes to support the other types. Currently we only support Booleans. The Blackboard is actually interesting because if the variable doesn't exist, we actually create it. So create variable if not found. So if we load up a dialog tree and then start running nodes, if there's a variable that it doesn't detect, then it will create it and set it to a default value. And default values are typically false and 0. In the future, we're going to expand the Blackboard system so that we can actually set defaults in the level. And then when the dialog tree runs, it will use those defaults instead of like creating one that's false or creating one that's 0. And this is useful if you want to have a variable that starts off with a value other than false and 0. And then we have our helper functions here. This one might be moved to our string utility or related. But basically what it does is it parses the new lines and quotes from our quoted string, which if we take a look at the dialog file, you can see that these are the quoted strings that are in question. So there's the /n, and then there's the /quote, and these are being parsed in this function here. And we're basically just replacing the characters. So this is character 0, this is character 1. We're replacing it with the escape character /n. So this is technically a single character in the text file, but the one that we see over here is actually two different characters. And so we convert that down in order for it to be rendered correctly by our game engine. And we also have the reverse, so we can actually write a quoted string to file. And you can see here, if we detect a /n, we write the two characters / and n, same for the quote. And then we have our load dialog from file, which basically goes through. It's a very simple function that just parses out the different values that you see here. So for example, if we find the bracket node, then we parse the node ID from that and load it into the variable. And we do the same thing for all of the different fields that we have in the text file. And then of course we have a corresponding write function that just fprints everything out. And also it uses the enum type to make sure that it prints and formats the correct values. You can see here we're actually not printing out every variable. We only print out the variables that we need for that specific node type. We could print everything out, but then we have basically an uncompressed file. Because remember, the dialog system uses a single dialog node struct, and then we discriminate that struct based on an enumeration. And this is a different approach than basically making like mini structures, right? You can make a struct for is false, is true, probability selector. We just don't deal with any of that because this is much simpler, and we can write simpler code such as the read and write functions that you saw. If we did an object-oriented approach where we did inheritance or we had multiple structures, we would have to manage a lot more code to basically serialize, deserialize, and also the dialog code would become very messy as it tries to step through and determine which thing to use. I find that the switch statement is just much more easier to jump through, and it's also more performant. The compiler is able to optimize that much more effectively than any polymorphic solution. Okay, so I guess the next thing to look at is the renderer. So if we go to the DirectX renderer, we're specifically going to look at the text renderer, which is actually going to be rewritten because it currently has a bug. But the important thing that I want to show here is what we do when we detect a /n. So you can see here, as we step through the text that we want to render, we're checking to see if there's a new line. And if there is a new line, we do some stuff here to basically move the line downwards. So you can see here, we grab the line width, and we have some other values like the advance, the kerning. Kerning's pretty interesting. I won't get into it, but I highly recommend looking into the terminology for text. You can learn quite a bit of neat things, and one of those is kerning. Highly recommend looking into that. It's pretty interesting. We use these values to basically calculate how far over to render the line or render the character. And then when we detect a new line, we actually move our line downwards. So you can see here, if it's a new line, we actually increment the line height, which we've calculated. If we look up here, actually we didn't calculate this, but we can calculate this. We can actually load it in from our true type font. Currently I just have it hard-coded to 32, so that's going to be improved. But basically, if we detect a new line, we move the characters down. And then when we generate our vertices, because our text is actually rendered as a series of quads, these quads will then appear on the correct line. So we can go back into Cultist here. Let me just make sure that there are no changes to our text file for the dialog. And let's talk to the tourist and take a look at a multi-line text box. So right here you can see this is a multi-line text box. It says, "Hey, fancy meeting you here." And we have this strange character right now. This is because I'm not loading in the entire font set. This is actually supposed to be a dash. I'm actually only loading in the alphabet from A to Z, and I'm not loading in special characters except for the exclamation mark. But dashes are excluded from that range currently. So I'm going to get that fixed up. But you can see this is correctly rendering a multi-line text box, and you can see it works for the other messages. And if we take a look at the dialog file, we can see up here the "Hey, fancy meeting you" is separated by the /n. And we detect that up here, and then we move the line downwards. And so this is basically how our text rendering works currently. Yeah, so next steps, we're going to keep expanding our game world. You can actually see here, we've been populating it with some assets to try to bring it up to par with our other levels. And so we're bringing back some of the gameplay from our Unity project. And we hope to add all the NPCs. We do have a town area, which is over here. This is going to look completely different when we're done, but you'll be able to talk to the various NPCs, get to know them, get to know the area. And our game is about cults, so we really want to explore the personality of the cult in this dialogue. And yeah, if you enjoyed this video and you want to see more, please consider subscribing and leaving a like. Also, if you have any questions or ideas for a specific video, also feel free to leave a comment below and I'll take a look at doing that for you. And for those who have commented previously, I am working on videos regarding memory management and spine, and those videos will be ready soon. Have a wonderful day, and I'll see you in the next video.